Hello everyone, this is our MRS22 Spring 2023 final part 1 review for question number 6. And so these videos are going to be hopefully helpful to you who are those individuals who have a little difficult time trying to figure out how to do some of the problems and for the final coming up and all. So this is our question number 6, which begins using a microscope. A researcher observed and recorded the number of bacteria and spores on a large sample of uniformly sized pieces of meat. Get the room temperature. A summary data is recorded shown in the table below. And this is our table. Using this data, write an exponential regression equation rounding all values to the nearest thousandth. So this is one of those straightforward, I would say straightforward though, but exponential regression problems. And so purely calculator. And so on the regions, especially when you do these problems and everything, they're kind of expecting you just to kind of just give them the information for this part, and of course ask you a second part using the equation you found. So to do this, what we want to do is kind of grab our calculator and enter our data. So let's get this calculator set up. So we have our graphing calculator here. I'm using the emulator for the TI-84. And so if you're using something else, like Inspire, sorry. So TI-84, if you're not using Casio, you have to figure out how to use a Casio here. So for TI-84, we want to get to the stats screen. So because we're doing a exponential regression, so we hit stat first, and then we're going to hit edit, which is choice 1. So it's enter. If in this case your columns are empty, fantastic. If they're not empty, what you want to do is bring your cursor up to the top and hit clear, not delete, clear, and hit enter. And it should clear out the entire column. All right, so ours are okay. So we'll enter in the values X we had, which were the amount of hours. So we enter our values here. First one was 0, and then 0.5, then 1, 2, 3, 4, and 6. That was from the table we had. And then we move over to the right side, one unit to make sure we're in L2, and now for the matching Y values. And so there were 4 spores at the beginning of the experiment, and then 10 spores after about half an hour, and then 15 spores after 1 hour, 60 spores after 2 hours, 260 spores after 3 hours, 1,130 spores after 4 hours, and after 6 hours, 16,380 spores. Okay? And so just make sure we have the correct information, all right? And so we can, we can check that and all. In this case, let's flip back to our screen here. Okay, yep, that looks okay, right? So let's go back to our calculator. Now, once we have information plugged in here, what we're going to do is go to stat again to make a calculation. So stat, this time go to the right one to do calculations. Now, here to do the exponential regression, we're going to bring the cursor down to past 9 to choice 0 because looking for exponential regression. So we'll have expreg. And so we hit enter. And now for X lists is L1, our Y list is L2. Now our frequency list, I'm going to clear that because we don't have frequency list here. All right. And then go to store regQ, that's clear. And then of course calculate, hit enter. And so the calculator is going to give us the Y equals A times B the X power. And so we're going to record to nearest thousandth what A was. So A is 4.1679, which rounds to 4.168. And our B value is going to be 3.981 because we go from the add 1 to the 0 because of the 6. Okay, and we don't need the R value, which is a correlation coefficient, though. So we're not using that for this time. So we're just going to go to back to our screen here and record. In this case, we're going to put down our A value. So A is equal to, we said here, 4.168, and our B value was equal to 3.981. The calculator gives the equation Y equals A times B to the X power. Therefore, the equation we're going to use is y is equal to 4.168, parenthesis 3.981 to the x power. And so this is going to be the answer we're going to use for the first part. Okay? So now you're going, okay, that's no big deal, right? Hopefully we're okay with typing the calculator and reading information and even copying down the equation of how the form of the exponential function. So we then take our information and scroll downwards a little bit because the next part says, the research shows that people are likely to suffer from foodborne illness if the number of spores exceeds 100. Using the exponential regression equation, determine the maximum amount of time to the nearest quarter hour that the meat can be kept at temperatures, room temperature safely. So that would mean for this use of the problem, we're going to set this, we want the equation to be less than or equal to 100. Less than or equal to 100. So that means 100, 100, we'll set equal to, in this case, we said it was 4.168 times 3.981 raise the x power. And we're going to solve for x. Okay? Now, again, nearest quarter hour, which means in this case, like, you know, because we have our x in terms of time, so we've got to be very careful with the nearest quarter hour. All right? Okay, so now again, what does that mean? We're going to round to nearest 0.25, or in this case, the maximum 0.25. So we might have to round backwards, because if we go too far ahead, then the meat's considered no good. Okay, so this is a log question. How do we know a log question? Because whenever the variable is an exponent, we're doing logs. And everyone first thinks with these log problems, the most common error students make, and you might make yourself, is you multiply the 4.168 with the 3.981. We can't do that though, because that violates our order operations problem. So instead what we're going to do is we're going to divide both sides. Our first step in most of these problems, all these problems, are going to divide by 4.168. Okay? Which leads us to, in this case, 100 over 4.168 is equal to 3.981 raised the x power. Now you see me put parentheses around stuff and all, right? And so the reason is because I'm going to leave it in this form. It might be easier to leave this here instead of rounding off and rounding off and rounding off and making an error and also. And so we said it was a log problem. So we will have to take the log of both sides. So I'm just going to move this up a little bit here. Okay. And then take the log of both sides here. So take the log of 100 over 4.168 equals to the log of 3.981 raised the x power. And the reason why we do logs is because there's a little rule that we can only use for logs called the power rule. And the power rule allows us to bring this exponent down to the front of the log. So now we have this equation, log of 100 divided by 4.168 equals x times the log of 3.981. And the reason why we do this is because now, even though these log things look very complicated, they're actually real numbers. They're not nice looking numbers. They're going to be probably decimals that run forever and not going to repeat. We'll call irrational numbers. But we can calculate them and use our calculator to help solve. So since we want to find x by itself, our goal is to now divide both sides by the log of 3.981. Okay, so now we have to use our graphing calculator to find this and all. So we want to take the log of 100 divided by 4.168 and divide that by the log of 3.981. So let's get to our calculator, right? We'll type it in hopefully properly. All right, let's clear the screen here, second mode. And so now we type in log, and we'll take, again, 100 divided by 4.168. And you might be asking in this case, Mr. Scott, why don't we just simplify that first? That number of 4.68 is already simplified, and every time you kind of round off again, it makes the answer less, it's a little further off and more of an error. So I want to make sure we don't have that also. So now we divide this whole thing by the log of 3.981. All right. Notice how just it would divide each number, right? Then we have to find each one and divide. This is fine. Hit enter, and so it looks like at 2.30015. Looks like pretty straightforward. Decimal-wise, 2.3 seems to be the best answer for this. So it looks like our time here, x is approximately 2.3. Now, this is hours, right? But this is not our answer because to nearest quarter hour. Well, okay. So nearest quarter hour, I would say nearest quarter, you might answer the following as, well, if I do quarters, like, quarter is 0.25, 0.5, 0.75, and and of course the 0 in this case. Well, at 2.3 hours, so the answer will be, in this case, 2.25 hours, or 2 hours and 15 minutes. Sorry, my handwriting's terrible. Sorry about that. So that would be the answer here, rounded off here, because that's for nearest tenth. That's for nearest quarter hour. And so that's how we use this here. Now I'm going to kind of mix the full page here to see the full thing. All right. Okay. Because asking for the nearest quarter hour, and we have to go backwards. I have to go backwards. Not rounding up to 2.5 hours, because by 2.5 hours the spored amount is too high. Okay. All right. So hopefully, hopefully they won't ask this weird question though, because on the regions, if you had to do nearest quarter hour, they have to know it's like, in increments of 0.25, which is, you have to be careful with that. Hopefully it's, on your test or final, and also on our, the regions and everything if a question comes up, because these questions are older regions questions. What happens in this case, maybe hopefully it's nearest 10th or nearest 100th of an hour, make things a little easier for us. Okay. All right, everybody. Hope this was helpful. And you should look out for the other videos I'll be posting for the other questions that will be on your final, but also stuff you should be looking out for the regions and everything. Hope this was helpful. Leave comments. Leave comments section below what you thought was helpful or not helpful. If you liked it, please give a like. And if you have not subscribed to my channel yet, please do so already. And of course, if you have any particular subject content that you'd like to post on, because I know this is a final for my Algebra 2 class and everything, but next year, you're taking pre-calc, hey, maybe you want to, ask, like, hey, could you cover this topic too? Which, I will respond to, hopefully, and be able to come up with topics in that section as well too. But thanks so much for watching, ladies and gentlemen. Take care of yourselves and be safe.